Well, hello everyone and welcome to this afternoon's session. Thank you everyone for being here, and if you're watching it live or online, we do appreciate that you are able to give the time just to come to this session. I'd like to especially welcome Beverly Maloney today. She's from the Royal Academy of Engineering, and she's a STEM teacher coordinator. So she's successfully built a large network of schools in her area using partnerships with local industries, including the NHS, police and armed and local engineering firms. As a teacher coordinator for the last 3 years, she's been able to continue to grow teacher participation and strengthen STEM learning throughout the area. She delivers CPD sessions to STEM teachers, including the Royal Academy of Engineering resources, in addition to organising multi-school collaborative projects. This year, Beverly collated over 21 local STEM representatives in the area and held the first ever regional STEM Fest, gathering hundreds of local school children together to celebrate STEM across all sectors in an afternoon of workshops and exhibitions. So we're really pleased to have Beverly here today, and she's going to be looking at a couple of Royal Academy of Engineering workshops, resources, and I can definitely vouch as someone who has used their resources myself quite a lot. They're really excellent, really worth doing. So thank you for being here, and I'll hand over to Beverly, who I'm sure will have some wonderful things to speak to you about. Thank you, Beverly.
Thank you, Michael, and nice to see you all virtually. My name is Beverly Maloney, and as Michael has just said, I've got an array of credibility, I suppose, and it's a real pleasure to be a part of this EdTech event 2020 over the last couple of days. So the EdTech Festival has asked me to talk to you today about the resources that Royal Academy of Engineering has on offer and can provide you with over the course of home learning, but certainly when we return back to school as well in September. In preparation for today's session, if you would like to kind of get involved and be interactive in this, then I would really encourage you to use the Q&A. It'd be really helpful for me if you could pop up, what your background is, whether you're a teacher, science, technology, any of the STEM or elsewhere. If you're primary, secondary, independent state, that would really help me kind of tailor the session. And of course, if you've got any questions that you want to ask about any of the resources or anything I talked to you about today, then please feel free to place that in the Q&A section, and we'll touch base on that towards the end or throughout. The other thing that I would like to encourage you to do, if you want to make this a bit more interactive for yourself, there are 2 apps. You only need to download one of them. This will support one of the activities in today's session. They're basically heart monitoring apps. One is for an Android and one is for an iPhone. So the accurate heart rate monitor and the cardiac heart rate monitor. And I'll bring that up as we go through the session as well. And of course, if you have a ruler to hand, that would be really helpful as well. So who am I? So I am a Goldsmiths graduate. I graduated in 2007, and I did the Bachelor of Education Design Technology degree. I then became a Chartered London teacher, having worked in London for over 7-8 years, and became head of faculty for those first 4 years. I then moved up to Essex, became a Developing Excellence in STEM coordinator, worked alongside Essex County Council, and supported local industries and local other schools. That led me into the role I'm in today, which is a STEM lead for a large independent school. I have worked in comprehensive for the majority of my teaching career, but very lucky to be an independent in the last couple of years. And my role in which I'm here today is I'm a teacher coordinator for the Connecting STEM Teachers Programme for the Royal Academy of Engineering. Very large title, but essentially it's the CST programme. So we work within the Royal Academy of Engineering. There are 52 of us to date across the country, and yourselves, you'll be working down in the southwest, and there'll be a teacher coordinator, a couple of, in fact, down that side of the country, and there's lots scattered around. And our aim really is to support schools in enriching STEM within your curriculum, in the most efficient and positive way possible. And we do that by providing resource kits, by providing additional support, by using all of the other bits and pieces that are already out there, like STEM learning, and putting them into one place. We also collaborate with industry. So if there was anything in particular that industry wanted to offer, then we, in our own areas, we then make those links also. The resources essentially apply engineering to the real world, okay, in the context of school and how you can build that within your own curriculum. The resources are there to support progression, particularly for students of unrepresented groups like women in engineering, for example, and to support post-16 and to get more engineers into the workplace. Like I said, there are actually 52 of us. This was last year's number, so 49 regional CST networks across the country. So, you know, that's able to support you. What I do in my role is I create these termly meetings. So this term I've done it online, naturally, as everyone else has, but normally you would see us within a school setting, within a college setting, within an industry setting, providing these meetings, and there would normally be a resource available at each of those meetings. This will allow you then to speak or to network with other teachers that are teaching similar content in the curriculum, in your own curriculum area, but also to kind of work with each other to see what else is out there. A lot of the time, a lot of stuff is free, and the Royal Academy of Engineering supports that as well. As Michael said, last year I held a collaborative project which involved 1,300 students from across Essex and Suffolk in the first regional event, STEM Fest, and that brought together just over 20 organisations to talk to the students, a little bit like a Big Bang Fair from, you know, the one we have in Birmingham, but on a much smaller scale, obviously. And that was really key as well. And your local area will also have similar things like that going on, collaborative events. And that's tailored to what the teachers in your network would like. The Royal Academy of Engineering not only do the STEM resource boxes, but we also provide and have been providing some online content for supporting students at home, just like lots of other people have. But you know, we've got competitions, resources that you can download for free online. And every 2 weeks we have this thing called STEM at Home, where students, whether it's part of your curriculum or not, can go onto the STEM at Home website and can access any of the resources and do those activities at home. Now, I'm sure this presentation will be available after this live session, and so what I've done is on this PowerPoint is I've created links so that you can access all of those bits of information in your own time. So there is a hub called STEM Resources Hub on the Royal Academy of Engineering website, and as I've alluded to, we have got several resources. Now there are lots of resources telling back about 5-6 years that are still very, very current. But particularly we've got the Power Up and the Lightsaver resource, which is what I'm going to go through with you today. And these are often very much hands-on activities. There are always going to be a teacher resource and a student resource. There is always a handling collection. So if your school wanted to provide that within a curriculum or within a club, then there are good guides there for you to do that. Also, you know, where you can buy things from in the cheapest way and how you can utilise the resources in the best way. So today we've got Lightsaver and Power Up. Power Up is to do with how energy works or how energy is used or transferred, generated within different elements of engineering. So it's an engineering based resource. The resource is actually resourceless. So there are no bits and pieces as you would normally expect to find in a typical Royal Academy of Engineering resource box. These are all digital resources. And the good thing about these resources this term, for me, certainly within my network, is that my teachers have been able to lift them digitally and provide them to their students at home. And the resources that I've suggested to accompany these digital resources have been things that students can find easily accessible within their own settings. That's not digitally based and certainly not reliant on any kind of funding. And so that's why Power Up and Lightsaber are good. So Power Up is to do with energy and how it's transferred, generated. And there's a couple of activities in there which we'll go through. And Lightsaber is all to do with light and how light is kind of transfers within the body, the brain. And Lightsaber is a really good resource because it's Royal Academy of Engineering have actually linked with UCL and Metabolite, which have supported this resource in terms of biomedical engineering. So as I said, these resources digitally are provided on the website. However, there is no reason why you can't create your own handling collection within your own setting. So I provided this particular set of resources, so marbles, torches, little wind-up toys, gummy bears, things that people can find or get at home. I went to my local pound shop and bought a couple of them just in order to send them out. If this is something you're interested in, the Royal Academy of Engineering can provide these resources for you as well, and just get in touch, and there'll be a contact at the end. So Power Up, like I said, is to do with energy and engineering. So we're talking about the different types of stores of energy, electrical, kinetic, magnetic, and so on, and how then that is transferred. So this is typically what you would expect to see in a regular science lesson. However, the resource supports how the energy can be used within the engineering context. And the resource talks about how you channel your energy, how it's generated. This is where things like the wind-up toy is quite good, and you can show that. Particularly me, I'm a design technology teacher by trade, but the essence of using something practical in order to show how that energy is transferred is priceless, and so I'd really encourage you to kind of use that in that context. Transfer energy, we've just talked about. There is a really fantastic guy called Lewis Matheson, and he does physics online. He's a teacher coordinator for the Royal Academy of Engineering as well. And what he's done is he's provided lots of hands-on activities in the form of video. So I am going to now pass over to Lewis, who is in this YouTube video, and these also accompany the resources that you can find online. So I'm hoping this will work. So I'm going to click on this and make sure my Wi-Fi is on tune.
Beverly, sorry about this. We don't seem to have your sound coming through at the moment.
Okay, sorry about that. Let me try that again.
In this video, I'd like to introduce a new resource which has been made by the Royal Academy of Engineering. It's called Power Up, and you can find it on their STEM resources website, where there's a student guide that you can download, as well as a short teacher guide that has all the answers inside it. Now, this is a great resource for students in Key Stage 3. It looks at energy stores and transfers, it looks at power, and also ways that we generate our electricity. And it's something that could be done in a STEM club at school, or also the students could have a go at home. Inside the resource, it starts by looking at different energy stores and transfers of everyday objects, which is work that your students will be familiar with from their science lessons. It then goes on to a really nice activity with an energy circuit. Now in the school you might be able to set this up using real life examples, but even at home students will have things like lamps and torches as well as wind up toys, and that means they can actually bring this science to life to think about how energy is stored and then transferred from one store to another. It also links up quite nicely with careers in engineering, and there's a great task where students can have a look at some images and try and identify some of the energy stores and transfers in these different careers that real engineers actually take part in. The next activity is brilliant for your students to get involved with, and it's making a Rube Goldberg experiment. This is something which does something very, very simple in a really, really complicated way. And there are some fantastic videos on YouTube of people who've made their own ones at home. So this is not only considering the different energy stores and transfers, but it's a great chance for your students to get hands-on experience about making something actually work. And even at home, they could do this around the house using everyday objects and make a short video or take some photos to show what they've actually achieved. The next part of the resource looks at the energy demands of society and how we actually generate electricity. So there's some information about global access to electricity. There's some information about how we actually generate this in power stations. And then there's also a really nice task which introduces some more complicated mathematics. So this is looking at the rate of energy transfer, which is the power. The last part of the guide looks at different ways that we currently generate electricity, as well as some of the future technology which is being developed by engineers. So this includes solar power, where there's a nice task where the students can do some calculations, including area and perimeter. And also they can have a go at making their own wind turbine. So this is something that the students could complete at home just using things like straws, string and paper clips. And what they could do is they could maybe design their own wind turbine. They could test it using a hairdryer held at a certain distance, and they could experiment with blade design or the number of blades to see which is the most effective design at picking up a certain number of paper clips. So again, this is something that your students could experiment with at home using readily available and cheap resources. So that is just a quick summary of Power Up by the Royal Academy of Engineering. It's really topical. It has some great curriculum links to the work that your students are currently doing. And also there's a lot of tasks which could be done outside of the classroom at home, including making their own wind turbine or making their own Rube Goldberg machine. If you would like to find out more information about this or any other resources that the Royal Academy of Engineering have put out recently, please have a look at the STEM resources page. Thank you.
Sorry, just making sure that I'm okay. So that was Lewis going through the Power Up resource, and as he said, talking about how we can use energy in lots of various different areas of life. And typically at this point in my networking session, I would get you kind of hands-on and making the wind turbine to create the power. Lewis talks about the Rube Goldberg experiment. Of course, that's one of the resources that are available in the box, but I'd also suggest looking at things like the Dyson challenges, because they provide some really good visuals as well for your students. And now we move on to the Lightsaver resource, and the Lightsaver resource is a collaborative project with the Metabolite team at UCL Engineering, and these are a team of engineers that typically work with babies, and of course anything to do with biomedical engineering, particularly in our current climate, it is vital in terms of understanding how light can be used in the context of engineering. Now, what I'm going to try and do now is show you the video that Metabolite have produced. It's a really good video to show your students as well, but this is the team of engineers at UCL. Okay. Hopefully this one works.
Light lets us see the world around us. But did you know that we can use light to see inside our bodies and measure our health?
Hi, I'm Josh, and I'm part of the Metabolite project here at University College London. We're a team of medical engineers, scientists and doctors Hello. And our work here involves light. In particular, we measure how light travels through the human body and use that to investigate important things about health. Now, you might not have thought the light can pass through the body, but some types of light do. Fong here is going to help me show you how a normal light source like this torch actually emits many colours of light. And to do that, we're going to use something called the diffraction grating. It splits light up into constituent colours according to their wavelength. And in the case of the white light from this torch, that's all the colours of the rainbow. At one end we have the shorter wavelengths like violet, whilst at the other end we have the longer wavelengths like orange or red. And just past the red colour, with an even longer wavelength, we have near infrared light.
This is the kind of light that we're interested in because it is this stuff that can travel far into the human body.
Light can reveal changing oxygen levels in the blood pumping through our body. Oxygen-packed blood is bright red, while blood that's had its oxygen used up changes to a bluer colour. Doctors use light to measure this colour change, then work out how much oxygen is in the bloodstream anywhere in the body. At the moment they do this using 2 or 3 specific colours from the light spectrum called near-infrared. We want to go further. By using the full spectrum of red and infrared wavelengths, we can get a much richer, more detailed view of the processes inside the body. We can also measure how oxygen is being used to produce energy inside cells. This is possible because these light wavelengths are able to detect an amazing process called metabolism. Metabolism takes place within the mitochondria. Mitochondria are miniature energy factories inside every cell in our bodies. If we can detect the colour changes within mitochondria in the brain, we can see how well our brains are working. So how do we shine light through the bones of the skull into the brain tissue and then detect it coming out the other side? Meet CIRL, which stands for Cytochrome C Oxidase, Research Instrument and Application. Gemma, the engineer who built this instrument in our lab, is going to describe how it works.
I built CIRL to illuminate the inner workings of the brain. It shines light into the brain via optical fibres, which are attached onto the forehead using tape. Any light that passes through the brain and reaches the surface again is picked up by another optical fibre and travels to a device called a spectrometer. The spectrometer splits the light into its constituent colours using a diffraction grating, creating a rainbow-like spectrum. It then measures the relative amounts of the different colours in the spectrum using a camera. Finally, a computer crunches this colour information to calculate how well the mitochondria are using oxygen and making energy.
One immediate and vital use for this new technology is to detect and monitor brain injury in babies caused by a lack of oxygen. This problem affects hundreds of thousands of newborns every year in the UK alone and is a major cause of serious conditions including cerebral palsy. In the worst cases, it can even lead to death. The great thing about this technology is that it's non-invasive, pain-free, cheap and can be taken to the patient's cotside or bedside, revealing essential, up-to-the-moment information about a patient. Best of all, it's completely harmless, just like shining a torch against your skin.
We're currently testing our lab-made instruments in clinical trials at University College Hospital. We're working hard to find out if they will be useful to help doctors diagnose and treat babies, children and adults with brain injuries.
If you want to learn more, please have a look at our website, metabolite.org.
Thanks for watching.
Okay, and so that is the from the Metabolite team at UCL Engineering. So this brings me on to the Lightsaver resource and what that provides. There is another video that I'm going to show you in just a second, but I thought I'd just introduce the resources first to you. So the resources that Lightsaver have offer you will go into what is like the electromagnetic spectrum, how that light behaves, particularly in the body, and how we might measure that light. And so there is a couple of things that I would like to do in terms of activity for you today. So just before I put the video on about the ins and outs of the Lightsaver resource, if you're able to get a ruler, or if you have one already, have that to hand, and I'll get you to do something with that in just a second. Just before I put this video on, it's really, really nice to see some people using the Q&A. If you've got any questions throughout, then please just continue to put them on there about about anything, and I'll try my hardest to answer them for you. But I'm going to show you now the Lightsaver resource in terms of what the Royal Academy of Engineering offer.
Hi, I'm Yasmin, and I develop STEM resources at the Royal Academy of Engineering.
And I'm Gemma. I'm a medical physicist from UCL Engineering.
And we're really pleased to be sharing with you guys a fantastic resource that brings together engineering, biology and physics and medicine for students in upper primary and lower secondary.
So the resource is in a student guide form, and then there's also a teacher guide with all the answers to the questions in the student guide.
The resource is available to download for free on the STEM resource website, on the UCL Metabolite page, and also available if hard copy if you join one of our Connecting STEM teacher program, which is also a fantastic way to meet other STEM teachers in your local area.
So Lightsaver is inspired by our work in the Medical Physics and Biomedical Engineering department at UCL. We develop light-based techniques to monitor the brain in hospitals. Essentially what we do is we shine light into the brain and we detect the light that comes back out, and from that we can find out a little bit about what's going on inside the body and use that information to tell doctors how their patient's doing. So in this first section, what is light? We introduce the concept of light, how it transfers energy. We introduce the electromagnetic spectrum and the different wavelengths that light can come in.
And as students who will be looking at really small numbers as part of this resource, we wanted to introduce an activity that gave them an understanding of what these really small numbers look like and how they compare to numbers that they're more familiar with. So we've included an activity which looks at the powers of 10, which asks them just to spot patterns, but hopefully through that can see the difference between what 10,000 looks like compared to 0.001, for instance. As well as the Powers of 10 activity, we've included a link to a fantastic interactive tool called the Scale of the Universe. Students can use this to compare the size of different objects to each other, but also to microwaves, infrared waves, radio waves. They can get a real idea of what these different sizes actually mean.
And because in this resource we're focusing on visible and infrared light, these are all measured in nanometers. So on page 5, we're talking about what a nanometer is and how it relates to objects in real life. So for example, we've got here some objects you might find in the classroom and we can measure them. So this pencil sharpener is 2.4 centimeters, and then we can convert that into nanometers, so that's 24 million nanometers. So hopefully that will give them an idea of the scales that we're talking about.
And to download a copy of the Lightsaver resource, including the teacher guide, student guide, and the case studies, you'll find all of this on the Royal Academy of Engineering STEM Resource Hub, in addition to links to UCL Engineering and to the Metabolite project.
Okay, so that was Yasmin and Gemma. Now Yasmin is one of the writers for this resource at the Royal Academy of Engineering, and in the Q&A she's offered her email address and contact if you would like any more information to do with this project or any other resources that the Academy provides. And of course you're welcome to contact her at any point. So as was suggested, there is an activity and the activity involves your ruler. So what I would like you to do, if possible, if you have the ruler there, and I'm hoping lots of you do, is to find an object. Okay, so I've got here my phone and I've got a ruler from BAE Systems, another freebie, because they do like a freebie, they do. And I'm just going to get my ruler and I'm going to measure it in centimetres. And as a design technology teacher, lots of students come in year 7, and although they might know what centimetres are and kind of that, but they tend to not know how to convert. Lots of the students that I've taught anyway. And so this is a really good, simple tool to do. So I'm going to attempt at doing something interactive now using the Q&A if possible. If you've got a ruler, and an object, if I can get you to measure it in centimetres, and then I'd like for you to convert it, please, into nanometers. So 1 centimetre is the equivalent to 10 million nanometers. And then if you could put your answer into the Q&A, that would be fantastic. I'm hoping for the best here. And that, you know, that's a nice simple activity. Students hopefully have rulers at home, and you can do that as a mathematical task or numeracy task if you wanted to. So whilst you're doing that, I'm going to talk you through another couple of activities that you can do. So this is the scale of the universe. This is a fantastic resource. It's web-based, but you can do this on a tablet or a phone. It works fine, and it also has some very, very soothing music behind it. So what I'm going to do is I'm going to go straight on to that web page. Actually, you do need Flash for this, but you'll see what I mean. So you essentially can move up and down the universe to the very, very smallest that you can't see. Okay, and then you can go right back to the things that are visible, things that we can see. So then we're starting to look at dust mites. We go back again, starting to now look at seeds, small animals, people, trees, mammals, and then of course as we get bigger and bigger we've got the larger landmarks in the world, and of course we come out of the earth and then into the universe, and this is quite a nice video to allow you to show perspective for your students. Okay, so I'm going to turn that off because as much as it is nice soothing music, we want to be able to hear the next thing. Okay, so where are we at here? So the Lightsaber resource is fantastic in terms of it offers lots of opportunity for small, very easy starter activities for you to do. And I can see we've got one person there using their phone. Fantastic. That's a very small phone. Oh no, I suppose, yeah, the width of that's quite, yeah, it's appropriate. And the resources, you know, they're very, very short, very convenient for students at home, as I said. And sorry, just making sure that it's the right thing. Okay, and you can also use gummy bears to show light through. Another experiment that I'd hoped to be able to show you today was just using blue food colouring in water to show how light might disperse in that. So all I've done here is in preparation, I've made a little note next to it to say don't drink it whilst I'm talking, but we've got there a blue food colouring just in a glass of water. Now, if you can't get blue food colouring, then I've used an old school ink cartridge and I've cut that into the water. But you can do things like shine the light through it. You can use Quality Street wrappers to see how that light might change. You can also add something like milk in it to see how the light might diffuse. Again, all things that students should be able to access at home. There are several videos that come along with this resource. I've only shown you the one, but it goes through how these activities might operate at home. The last thing I would like to talk to you about is using the heart rate monitor. So on your phones, you will hopefully have downloaded one of the heart rate monitors. And what you can do with that is you can essentially work out how the light on your phone can be used to work out your heart rate. And as much as that doesn't seem like it should be happening, that torch element is just as good if students don't have torches at home. Okay, so I would encourage you to use that as well. I'm very, very conscious of time and any questions that you may have. And so before I kind of finish off today, be aware that the Royal Academy of Engineering do work alongside other people in terms of competitions, and there are lots of things going on around at the moment. I've recently been doing the Great Exhibition at Home competition, which has linked the students up with several engineers, resources where students have been quite creative, and they're very open competitions as well. And I've just been talking to them about the possibility of another competition next term. So keep a lookout for other things that are going on. In terms of today's session now, that's me. Very whistle stops tour of the lightsaber and the power up resources from the Royal Academy of Engineering. There are lots and lots of other resources for you to access should you wish to. But if you would like to be a part of the Connecting STEM Teacher Network, then please do get in touch. The website's, the email address is there, education@ran.org.uk. Yasmin, who is one of the team at the Royal Academy of Engineering for the CST programme, has also offered her personal address there at the Academy, yasmin.farmy@ran.org.uk. And of course, if you would like to talk to me about anything that I do within my network, or you would like to get in contact with me about anything else about my design technology or experience as a STEM coordinator, then you're more than welcome to contact me also. I think in terms of questions, we haven't had anything come forward since primary and secondary, but lovely to see people to measuring and having rulers easy accessible. I actually had to hunt high and low for a ruler in my house, so hopefully that's not typical for your students. But please feel free to follow, to retweet. We're constantly putting things up on Twitter and Facebook, and you're more than welcome to get involved as and when and how you wish. But for now, thank you very much for your time. I hope you enjoy the rest of the event today. And if you would like to contact me, please do. Thank you, Michael.
Okay, well, thank you very much, Beverly. Thank you very much, appreciate that. Really interesting. I do recommend having a look at the Royal Academy of Engineering resources, everyone, if you haven't looked at them before. And of course, if you have used them, then please continue. They're really good. We use them a lot here. So thank you for joining this session. I hope it was useful, and as Beverly said, do get in touch with them or with us if you want any further support, and we can point you in the right direction. So thank you for being here today, and have a lovely rest of your Tuesday.